Good day, welcome to another video. We are continuing with functions. Basically, we're doing a question which combines a parabola and a hyperbola. So here we're given graph of f of x, and then we're also given a graph of g of x, okay? And we are given the turning point of f as c, and then it also passes through the x-intercept at 1 is to 0. And then we're given that d is the y-intercept of both f and g. Okay, so yeah, basically it's their intercept. Okay, and then we're also told that f and g also interact at e and j. Okay, so and then we're also given the vertical asymptote that it passes through the x-intercept of f. Okay, so yeah, from this we are then asked what is the value of p. So the value of p is actually equal to -1, okay, using the formula that it gave us, x plus p, right, a over x plus p. But then remember what I showed you guys, it was us having to use a basically over x minus p. Okay, so how are the two different? Yeah, the two are different in that, yeah, using this one that we given here, p will be -1, right, since it is basically a over x plus in bracket -1, okay, which gives us a over x minus 1. But then had we been given this, it will just be a over x minus in bracket +1, right, which is still a over x minus 1. Okay, so the two are basically one and the same thing. It's just a matter of you understanding how p basically affects the graph, right? But the two are basically the same. So just note that when you have x minus whatever value, shift is where shift is to the right, right? The graph shifts horizontal to the right. And then when you have x plus whatever value here, basically your graph shifts where it shifts to the left. So it does basically the opposite of the sign, okay? And another thing that I don't know if this will is also maybe make things much easier to understand or not, but let's just look at this arm, right? So basically, think of it also in this way. We have a over x minus whatever value we can have here. So basically, when we have a over x minus whatever value, this in effect, it does what? We have y is equals to this, right? In effect, when we are dividing by a smaller number, it's as if y grows, right? So instead of y being basically very steep right here, as we know in the original graph, right? Instead of it being very steep here, since these values, they grow very fast before even reaching that value, since we were subtracting, so that value might have grown to the very same level 1 unit backwards. I hope that maybe also brings some clarity, but I will also explain in case some of you don't understand. You can request for a video with me explaining that. But the original graph here, it would be something like this, right? And then this one that we have basically shifted it by 1 unit to the right, okay? Yeah, but that was 1 mark. In any case, let's not waste time. 4.2. Okay, 4.2, they say show that a is equals to 3 and b is equals to 2. Okay, now we're given g of x being equals to a over x. Okay, let's just substitute. Okay, a over x minus 1. Okay, of which from this this here is basically y over x minus 1. And then do we have any point that we can substitute for x and y so that we can get our a? Let's check. Okay, Yeah, so we do have a point, and then our point is what is point D, where the two graphs intersect, right? But then how are we gonna find D? It's easy to find D since we are given f of x as x squared plus bx minus 3. We know that basically this will be the y-intercept of our graph of f, right, which is the same as the y-intercept for g since the intercept there, right? You can go on and find your intercept by saying this equals to 0, by letting x is equals to 0, but we, in the interest of time, let's move. So yeah, basically we're gonna have the point, we're gonna end up with a point 0 to negative 3, of which negative 3 is equals to a over 0 minus what? 0 minus 1. Therefore a becomes 3, right? And then how about b? We're given f of x squared plus bx minus 3. Okay, of which from this we can substitute. How many points do we have that we can substitute? Since we want b, so we can substitute for x and y. Okay, but then how many points do we have? We have a point at D, and then so do we have a point at the asymptote, right? The vertical asymptote at 1. But then we have to substitute the one where x is not equals to 0 instead of at D, since should we substitute that one of 0 is to negative 3, it's gonna end up affecting our b to be 0. So in essence, we won't even be solving for b. So the point that we're gonna use is which one? Is the one of 1 is to 0. Okay, so yeah, let's substitute. We get 0 is equals to 1 squared plus b 1 minus 3. Okay, therefore 0 is equals to negative 2 plus b, of which b is equals to 2. Yeah, then from that 4.3, they say the coordinates of c. Okay, so the coordinates of c, for us to find this one, since we now basically have our graph, we know that what's our equation? 4.3 f of x is equals to x squared plus 2x minus 3, right? Of which we're gonna use this one to therefore find our values of c. And we know that at c, basically it's at the turning point, right? And then what happens at the turning point? At the turning point, we know that basically x is equals to the x value there is negative b over 2a, right? The x value there at the turning point is negative b over 2a, of which negative, what is b? B is 2 over 2, and then a, we know a is 1. Therefore, the value there is negative 1, right? And then, okay, from that, we're gonna have to use this coordinate to find the respective y there. So the y value there will basically be, we substitute into the original equation, right? So this, we're gonna have negative 1 squared plus 2 negative 1 minus 3, of which this is gonna be 1 minus 2 minus 3, which all in all gives us 4. Okay, therefore c is equals to negative 1 is to negative 4. Okay, yeah, but also speaking about the x coordinate, in case maybe you had forgotten about this method, another way of finding the x coordinate is basically, it's, I think it's long, yeah, but you can factorize this, right? X minus, oh, okay, yeah, minus 1 plus 3. And then from there, x goes to 1 or x goes to negative 3, right? Of which x, it's x middle point, right? It's, yeah, the middle, this x value, it's in between the two x values, right? At the turning point. It's in between these x 2 points. So it's basically 1 plus in bracket negative 3 over 2, which still gives you what, negative 1. So both methods are correct. Yeah, so I was just showing you in case you might not be comfortable with one method. And then 4.4, they say write down the range of f. Okay. 4.4, the range of f basically is y is to the element, is y is greater than or included negative 4. Why is that? Looking at our graph, what is the lowest point? We noted it was negative 1 is to negative 4, right? The graph is true so in where all the y values are going up, are greater than negative 4. Okay, so it's basically y is greater than or included negative 4, where we know y is to the element real numbers, right? Y is real numbers. Okay, so yeah, we're done with that one. And then 4.5, they say determine the equation of line through C that makes an angle of 45 degrees with the positive x-axis. Write your answer in the form y. Okay. Yeah, so just gonna do that now. Okay. So 4.5, let me just draw this here now so you can see. Okay. Apology if my sketch won't be as accurate, but basically this is a line that is something like this. Yeah, let alone this is not drawn to proportion, so doesn't necessarily intercept here. Okay, but then in any case it makes a 45-degree angle. As they said that it makes a 45-degree angle with the positive x-axis. So this line, it starts all the way from C, negative 1 is to negative 4. Okay, and then it goes all the way up. But then what do we know is that the equation of a straight line is y is close to mx plus c, right? Of which, let's begin with our gradient. What will be our gradient? We know that another way of finding gradient is what? It is saying m is m, whereby it is tan of theta, right? Gradient is tangent of theta, of which tan of 45 degree gives you what? 1. Okay. Yeah, but in any case, yeah, at 45 degrees, both x and y are rising at the same value. So when one changes by 1, the other one changes by 1, which is, yeah, gradient of 1. Okay. So now you have this. You basically have x plus c, right? Okay. And yeah, since here we have that invisible one. Okay. So what point do we have on the graph? Remember, we have point C. So here we can substitute point C, right, to find this other C. Yeah, they just happen to be the same. Okay, negative 4 is to negative 1 plus C. So what therefore becomes our C? Our C therefore becomes negative 3, okay? Therefore our Y is equals to x minus 3 is the equation of the graph that they asked for. Okay. Then 4.6 is the straight line determined by in equation 4.5 a tangent to f. Explain your answer. Okay. Is it a tangent? Okay. Yeah. So what will have to happen for it to become a tangent? You can just come back here. Yeah. For it to be a tangent, remember that it will basically have to touch a one point. If even this line here is a tangent, right? Since it only touches where? This point, right? A line here is a tangent. Since it touches what? One point, okay? So even this is a tangent if it touches one point. So with this line here, they're asking whether it will be a tangent or not. Okay. So here what we notice is what? We notice that one first thing to note is what? Our its y coordinate, its y intercept basically is what? Is it will be what? 0 is to -3, right? Its y-intercept. You can calculate that by letting s equals to 0. Okay, its y-intercept will be 0 is to -3. And then remember, where did we have 0 is to -3? 0 is to -3 is point D. Okay, so in essence, what we have here, is something like this. Okay, C and then D. Okay, this line, this line, yeah, it's 45-degree, but I'm just illustrating now, not to proportion. It touches how many points? Let's look. 1, 2 points, right? Since we know that the other point is D. Okay, so from this, what is the conclusion? No, it is not a tangent. Why? It touches or crosses 2 points, right? 2 points on the graph. Okay, and now let's move to question 4.7. So in 4.7, we're told that h of x is equals to f of m minus x plus q, and then there's only one x-intercept at x equals to 0. And then they say determine the values of m and q. So here, the first thing to note, which is very important, is that we have one x-intercept at x is equals to 0. And for us to solve for our m and q, we're going to use both the graphical and then the mathematical method. Okay, so first thing we note in our graphical method is that whichever way we solve for this, the graph that we'll basically end up with, it will basically be a graph that looks like this, or it will look like this. And why is that the case? Let's note here that it has one x-intercept at x is equals to 0. For a graph to have one x-intercept at x equals to 0, that is basically the origin, right? So it's either the graph will end up facing up or down, but in any case, it has to pass through the origin with one root or one x-intercept, you know? Yeah, so it touches the exists once. Okay, so graphically, I'm just gonna begin with the graph of f of x, which we know is equals to x squared plus 2x minus 3, right? We were given this. Okay, and yeah, let's just first sketch that one here. Okay, x and then y. We know there was 1, -3, -3, and then point C, which was -1, -4, right? Okay. Okay, so this is basically our graph of f, right? Okay, so now we want a graph that will basically end up being like this. This graph is gonna move here, or it's gonna look like this. Okay, I hope that makes sense. So how is it gonna get there? That is the real question that we have, right? Of which now, let's move forward then. One thing we will notice is what, okay, we are given f of x being equals to s squared plus 2x minus 3. The graph of h of x, which we are given being equals to f of m minus x plus q. This graph, in essence, if you are to look at it, is in the most simplest way, right? Where we are used to f of x and stuff. So this is basically f of minus x minus m, right, plus q. This is the graph in essence. And then remember that when it is expressed like this, what we basically have here, it's maybe something like f of minus x minus p, right? Remember p? Okay. So yeah, it is something like that. And what does this negative right here basically mean? The negative inside in front of the bracket. So let's look at it. When you have f of x, right, and then you are told that h of x is equals to f of minus x, okay? If ever you started with a graph like this, okay, which is the one we are given, when you now have f of minus x, that basically means what? It basically means that every other x value, you have to negate it. You have to make it the opposite of what it was before. So here we have what? We have 3, right? Therefore, we have negative 3. Therefore, here we're going to have positive 3. Where we have 1, we're going to have negative 1. So this graph looks something like this. Okay, makes sense? So this is basically a reflection about what? About the y-axis. Okay, y-axis reflection. Okay, and then remember we'd also have something like f of x, and then we'd be told that maybe h of x is equals to f negative f of x. Okay, these, remember, that is basically just like negative y. So here you have to what? Negate all the y values. So this looks like this. Therefore, this is gonna look like what? This is gonna look something like this, okay? Which is a reflection about the x-axis. Okay, so it was reflected about the x-axis. But then in our case, which graph do we basically have? The graph, the reflection we have is this one, right? Since we have this negative here, okay, that we have case 1, I mean. So basically this is the graph we have, okay? As you can also see here, f of minus, right, sorry. And then yeah, from that, what is the second thing that happened? Looking at the graph, that we've already taken care of this, right? We have already taken, let me use green. We have already taken care of this. So now let's deal with x minus m. And then also let's deal with q. The first one, which is much easier to deal with, is what is q. Ne? So first thing, let me maybe write the first graph that we have. It's gonna be a graph like this. And then here, remember we have 3. We're gonna have negative 1. So our graph is gonna look something like this, right? Okay. And then we've taken care of the negative. Now let's take care of q. Taking care of q, it means that this graph, for it to be aligned with the x-axis, remember that it has to end up here. It means that we have to move it vertical how many units? 4 units. So these are the 4 units. Meaning what? Our q is equals to 4. Okay. So this is the new graph. Should we move it 4 units up? So this is the new graph. So we've already established that q is equals to 4, given that for it to be on the x-axis directly, it has to move 4 units up. But then for it to move then to what? For it to then move to the origin, right? Because remember what we have here is what? Is f of minus x minus m. right? Plus q. Using x minus m, what you notice is what? Is that, as I've said earlier on, when we have, what we are mainly interested in is what? Is that at the end of the day, negative means that we are moving to the right, and then positive whatever here means we are moving to the left. Okay, in this case we have negative, so for us to therefore end up moving to the left, right, it means that this sign must be positive, right? How is it going to be positive? Is if ever m is negative, therefore m is equals to -1, right? So this is basically x minus, in bracket, -1, which is x plus 1. Okay, so that therefore tells us what m is equals to -1. I hope that made sense. So the final graph that we have is this right here. Okay, that is the final graph we have, which is just here. So that is the graphical method. Yeah, I hope I made a lot of sense. But then now let's move on to the mathematical method. Remember, f of x is equals to x squared plus 2x minus 3, right? And then we're given h of x being equals to f of m minus x plus q, right? In such a case, whatever we have here, instead of having x as we had x before, x basically now becomes m minus x. Okay, so in essence we have h of x, which is equals to, in bracket, m minus x squared, we're substituting over here, né? And then plus 2 m minus x, okay, and then minus 3. And then at the end, remember that we have what? Plus q, which is what? Which is 4. Because in any case, even using this other mathematical method, we will know that our q is 4, given that for it to just move to the origin, for it to move from this level all the way up here, it will have to have moved by how many points? 4 points. Okay, so yeah, from that, one thing we know is what? We know that at the origin both points are 0, right? So we can maybe just substitute 0 is to m minus 0 squared plus 2 m minus 0 plus 1. Okay, here we end up with 0 being equals to m squared plus 2m plus 1. Here is basically 0 is equals to m plus 1, m plus 1. We have the same root, right? Same root for m. Yeah, so m is just equals to -1. Okay, I hope, yeah, this made sense. Thank you for watching the video till the end. Kindly stay tuned to watch more interesting math videos. Thank you.